Hello and welcome to DotNet in Minutes. Today we are going deeper into one of the most powerful and misunderstood features in .NET, Dependency Injection or DI. You have probably written this code 100 times. Builder.services that add scope, user service, user service. But have you ever stopped to ask what really happens behind the scenes? In this episode, we will peel back the curtain and explore how .NET creates, manages, and disposes of dependencies inside your applications. What DI actually does. Dependency injection isn't magic, it's a pattern. It means your classes don't create their own dependencies. Instead, they ask for them. The framework takes care of constructing, wiring, and managing their lifetime. Imagine walking into a restaurant. Instead of cooking your own meal, you just order. The system, means the kitchen, knows how to prepare it and hand it to you. That's what dependency injection does for your classes. Behind every DI system in .NET, there's a service container, sometimes called the inversion of control container. When you call builder.services that add scope user service, you're registering a mapping. You are saying when someone asks for user service, give them an instance of user service. The container keeps a registry, a dictionary that looks something like this internally. I user service to user service. I email sender to email sender. I logger to logger. Then, when your controller asks for a dependency, the container looks it up, build it, including its own dependencies, and injects it automatically. When your controller runs, .NET uses something called constructor injection. Let's say you have a class like this, a user controller. When the app starts, the DI container checks. Does user controller need anything? Yes. User service. It finds that in the registry, creates user service and passes it into the constructor. If user service itself depends on iLogger, it builds that first. That is called recursive resolution, building the dependency tree automatically. Lifetime management. Now, here's where it gets interesting. Lifetimes. In .NET, each service has a specific lifetime. Transient, a new instance every time. Scope, one instance per HTTP request. Singleton, one instance for the whole app. The DI containers keep internal caches for scope and singleton objects. When a request ends, it disposes of scope dependencies automatically. So, when we call add scope, .NET keeps that instance alive just long enough for one request, and then cleans up to prevent memory leaks. Reflection and activation. Let's talk about how .NET actually builds your objects. When you request a service, the container uses reflection to inspect its constructor parameters. It looks like this under the hood. Find the constructor. Check what parameter it has. For each parameter, resolve it from the container. Create the object using activator utilities that create instance. This process happens incredibly fast, but you can imagine how much coordination is going on under the surface every time you hit an endpoint. Disposing dependencies. When a scope request ends, .NET automatically calls dispose on disposable service. This is critical for things like DB context. If you forget to mark your service as scope, your database connections might say open too long, causing timeouts or connection leaks. The DI system tracks disposable objects so it can safely tear them down. It's like garbage collection, but for your dependency tree. Custom factories and conditions. Sometimes you need more control. Maybe your dependency changes depending on configuration or context. You can register a factory instead of typing. Like this. Builder services add scope email sender. var config equal sp get request service. Require service. and the rest of the text. This gives you total control over how the instance is created, still managed by the AI, but customize your own app's needs. Common pitfalls. Let's finish with what you can go wrong. 1. Mixing lifetimes. Injecting scope into Singleton. 2. Overusing Singleton for everything. 3. Forgetting to register a dependency, no reference exception on start. And 4. Creating services manually instead of letting the AI to do it. The rule of thumb. If your class has dependencies, register it and inject it. Don't new it. So, to recap, the service container builds and manages your dependencies. Lifetimes keeps your app efficient and safe. Deflection powers constructor injection behind the scenes. Once you understand this, you can read your startup file like an orchestral score. Everything wired perfectly in sync. Thanks for listening to DotNet in minutes. See you in the next one, guys. Bye bye.